Hi, I'm Hayden from a robotics team called Trivium Nightmares, and I'm very excited to share what we did over the summer with you guys. We partnered with our local government and a charity organization in California to produce 200 STEM kits for those in need and our local community. The goal of these kits was hopefully to inspire people to get involved with STEM while also learning and enjoying fun experiments. Along with the kits, we included videos which went over the experiments, the science behind them, and the implementations of these sciences. And we thought it would be a really good idea to share these videos with you guys. Originally, all the materials that you would need to do these experiments were included in the kits. However, it's all household items, so you should be able to follow the experiments at home if you want to. There are 4 total experiments, and all the materials that you will need are down in the description. We hope that you enjoyed these experiments as much as we enjoyed making the kits and these videos. Enjoy! Hello everyone, I'm Hayden, and in this video we will be doing the soap circle experiment. This experiment is one of the more complex, so this experiment might take some time. For this we will need to grab the soap, string, and straws from the box, as well as a large container like a wide plate or tray and some water. We recommend substituting the included soap for some liquid dish soap, but the included soap should work. For the sake of the video, we will be using the included soap. Our first step is to make a frame out of the straws. To do this, fold the ends of one of the straws and slide it into another straw. Try pushing the straws all the way into each other for a sturdier and smaller frame. Repeat this process with the other straws until you have this shape. Lastly, we need to connect the ends of these 2 straws to complete our frame. It should look like this. Before this next step, tie your string into a loop. You might need help with this. Our next step is to make our soap solution. Take your container, add enough warm water so that when you put the frame into the container, it can be completely submerged, and add a block of soap to the water. We found that the best way to get the water soapy is to rub the soap into your palms and wash off the suds into the water. Keep doing this until when you lift your frame out of the water, it can create a bubble film. Now take your string and get the soap solution on it. Place it off to the side before this next part. Place your straw frame into the water, making sure to completely submerge it. Then, carefully lift it out of the suds. Now, you should hopefully have a soap film covering the frame. If not, just keep trying. Next, place your string into the soap film. You might need help with this step. Lastly, pop the bubble in the inside of the loop. Now you should have a perfect or almost perfect circle suspended in your soap film. The reason why it is a circle is because the soap film is pulling on all parts of the string equally, so there are no corners. This is the same reason why planets are spheres. The gravity of the planet pulls on all the rock at the same time, so it forms a sphere. This also means that if you have any amount of string, a circle made out of that string will have the most area than any other shape you can make with that string, because the extra string isn't wasted on corners. The last fun fact about the string is that we have cut it at a certain length. If you measure the diameter of the circle, so how wide it should be almost 2 inches wide. This is because the equation for the circumference of a circle is circumference equals the diameter times pi, and we made the circumference about equal to 2 times pi, which means that the circumference should be about 2 inches. This simple equation is the basis for everything from how we make tires, to how we explore space, to how you're watching this video right now. Thank you for doing this experiment with me. I hope you enjoyed the STEM kit, and don't forget to subscribe. Also, show us your completed experiment on Instagram with your parents' or guardian's permission by tagging us at trivium.nightmares. Hello everyone, I'm Hayden, and in this video we will be doing the Popsicle Stick Catapult experiment. For this you will need 5 popsicle sticks, 3 rubber bands, and a plastic spoon from the box, and either foil or paper for launching. We have included 2 spoons in case one of them breaks during this experiment. Our first step is to take off the left and middle rubber bands, trying to keep the stack of popsicle sticks together. Next, take the spoon and place it between the second and third popsicle sticks, as shown. Lastly, tie the rubber bands around the end and around the spoon if you can. Now you have a catapult. Ball up some paper or tinfoil and see how far it goes. This catapult works by converting potential energy into kinetic energy. As you pull back the arm, you may notice that the rubber bands stretch or the plastic spoon bends. This stretching and bending stores the energy that you put into the arm when you push down and releases it all at once into your projectile. In fact, the energy in the flying ball is equal to the force that you put into the arm. At least it would be if we include friction and other forms of energy into our equations. This is called the conservation of energy and is the basis for all of science. It's why a car can't stop instantly, it's how we generate power, and it's how all mechanical devices work. Try experimenting with the Catapult to see how far you can get it to launch things. Thank you for doing this experiment with me. I hope you enjoyed the STEM kit, and don't forget to subscribe. Also, show us your completed experiment on Instagram with your parents' or guardian's permission by tagging us at trivium.nightmares. Hello everyone, I'm Hayden, and in this video we will be doing the surface tension raft experiment. For this experiment, you will need the 2 paper clips found in the box and a glass of water. For the sake of the video, we used a large glass container, but any cup or bowl will work too. This experiment is a little simpler, but still fascinating. First, try to make one of these paper clips float on the top of the water. You might find that it's rather difficult. This is because the paper clip slips past the water and falls to the bottom of the cup. This effect can be seen more if you use larger paper clips than the ones included in the kits. However, we can still get these paper clips to float by using the surface tension of the water. Take one of your paper clips and bend it like this. Then place your second one on top of that one like this. Now slowly lower this whole contraption into the water until the paperclip floats and you can carefully take out the bent paperclip. As stated before, this works because of the surface tension of the water. You might be able to see that the water is bending a lot around the edges of the paperclip. The water is bending like this because the molecules of water really like being next to each other. They create small bonds between themselves called hydrogen bonds. These bonds can be easily broken, which is why you can go swimming or take a shower and not be trapped under the water. In the drop of water, the molecules are moving around and forming these small bonds at random. However, on the surface of the water, these molecules form a chain between themselves and create a net of molecules. This creates tension on the surface, which is why it's called surface tension. The paperclip is able to rest on this net, allowing it to float on the water. Surface tension is the reason why water forms drops and is how clouds form. It's also how some bugs skid on top of the water, and why sometimes when you pour a glass, it goes down the side of the cup. Thank you for doing this experiment with me. I hope you enjoyed the STEM kit, and don't forget to subscribe. Also, show us your completed experiment on Instagram with your parents' or guardian's permission by tagging us at trivium.nightmares. Hello everyone, I'm Hayden, and in this video we will be doing the center of mass experiment. For this, you will need to cut off a part of the box and a pencil. For the sake of the video, we used a larger piece of cardboard and a Sharpie. If you want to keep the STEM kit box, feel free to use another piece of cardboard too. This experiment is more conceptual than the other ones, but it's still interesting. Take your cardboard and cut out a random shape. You may need an adult's help with this. Try to make this shape bigger rather than smaller. Next, pick up your shape from a random point and allow your shape to swing down, like this. The closer to the edge of your shape the point is, the better. Draw a line from your finger towards the floor with your pencil. Repeat this process from another random point on your shape, as I have done here. Try to make these points farther apart. Lastly, take your pencil and try to balance your shape on the point where these 2 lines meet. You will find that it will balance on this point, or a point close to the one you found. This is because you have found the center of mass of your random shape. If your shape is too curved and the 2 lines meet outside the shape, then cut a new, more circular shape and repeat the process. Here's how this works. The center of mass always wants to be as close to the ground as possible. So when you pick a random point on your shape and let it hang, the center of mass will be directly under your fingers. This works for any point on your shape, not just the 2 you made. Try it. The center of mass is on every one of the lines that can be made, which means that all lines will share that point. This is why where the 2 lines crossed was the center point. They shared that point. Try holding onto your shape at the center point. You will find that your shape won't move. This is because the center of mass is just that, the average point of all the mass. So there is no weight to pull the shape down. This is the principle that allows wheels to work. The center of mass of a circle is its center, so the axles of all wheels are in the center. In fact, if you look at a car, you can see weights on the tires that make sure the axle is balanced so the car won't wobble. It's also important for airplanes, rocket ships, and any other thing that flies. Lastly, all of the laws of motion and fundamental physics equations rely on the center of mass, and you can imagine how important those equations are to our modern world. Thank you for doing this experiment with me. I hope you enjoyed the STEM kit, and don't forget to subscribe. Also, show us your completed experiment on Instagram with your parents' or guardian's permission by tagging us at trivium.nightmares.